So let's start some numericals from exercise 2C, which is basically on equations of motion. Before we start, let me highlight the three formula that we've done. V is equal to U plus AT, V square is equal to U square plus 2AS, and S is equal to UT plus half AT square. V is final velocity, U is initial velocity, A is acceleration, T is time, S is the distance traveled. So let's read the question. Question 1 says a body starts from rest. So let's start writing what information we have given. Body starts from rest, which means initial velocity is 0 meter per second. Perfect. With an uniform acceleration of 2 meter per second square. So acceleration is 2 meter per second square. Find the distance covered by the body in 2 seconds. T is equal to 2 seconds and I need to find S. So let me see which formula I can apply. This doesn't have S, this has S, but for this I need to know the final velocity. I don't know the final velocity yet. This formula has S, U given, T given, A given. So let's apply this formula. S is equal to UT plus half AT square. U is 0 multiplied by time is 2 plus half into acceleration, which is 2, multiplied with time square, which is 2 into 2, which is 4. So 2, 1, 2, 2 gets cancelled, which is equal to 0 into 2 is 0. This is 4 meter. Easy? Yeah, I guess it's very easy. Let's move on. Let's try and solve question number 2. A body starts with an initial velocity of 10 meter per second. Again, let's write what we have. Given is U is equal to 10 meter per second and acceleration of 5 meter per second square. Acceleration of 5 meter per second square. Find the distance covered by it in 5 seconds. T is equal to 5 seconds. S is equal to question mark. Exactly the same as this. We will apply the same formula. S is equal to UT plus half AT square, which means U is 10 multiplied with time, which is 5 plus half into A is 5 into time is 5, which is 5 square is 25. So this is 50 plus 25 into 5, 125 upon 2, which is 62.5. 62.5 plus 50 is 112.5 meter. Let's move on. Let's solve question number 3. Question 3 says a vehicle is accelerating on a straight road. Its velocity at any given instant is 30 km per hour. So the first velocity is given as 30 km per hour. Perfect. And then it changes to, after 2 seconds, it is 33.6 km per hour. So T, after T 2 seconds, new velocity, which is V2, become 33.6 km per hour. The time is given in second, velocity given in hour. So let's calculate and convert this into meter per second. So this will be 30 into 5 upon 18. This is 6 into 3, 6 into 5. This is 25 upon 3 meter per second. Again, let's also convert this 5 upon 18. This works out to 28 upon 3 meter per second. Next line, it says again after 2 seconds, it is also again 2 more seconds pass and velocity 3 is 37.2 km per hour. Let's convert this also into meter per second multiplied by 5 by 18. This is 31 upon 3 meter per second. So this is the first change and this is the second change. So initially it travels for 2 seconds and then it travels for 2 more seconds. At this point of time, the velocity is 30 at here the velocity is 33.6, here the velocity is 37.2. So this is the three different instances which are given. Let's see what the question asks us to do. The question is saying calculate the velocity, calculate the acceleration in meter per second square, and is the acceleration uniform, which means from here to here what is the acceleration, and from here to here let's call this A2, what is the acceleration. Well, I know acceleration, I know A is equal to final velocity minus initial velocity upon time. So for first instant, acceleration 1 will be equal to 28 upon 3 minus 25 upon 3. So it increased from 25 to 28 in total time, which is 2. So 28 upon 3 minus 25 upon 3 is 1, 3 upon 3 upon 2, which means this is equal to 0.5 meter per second square. Let's look at acceleration 2. Acceleration 2 is 31 by 3 minus 28 by 3, final velocity minus initial velocity upon total time. Again, the total time is 2 seconds. So this is again 31 minus 28 is 3. So this is 1 upon 2, which is 0.5 meter per second square. So acceleration 1 is 0.5, acceleration 2 is 0.5. Question is the acceleration uniform? Yes, it is uniform acceleration. Let's go to question number 5. Question number 5. Question number 5 says a bullet initially moving with a velocity of 20 meter per second. So initial velocity is 20 meter per second. This is given. Initial velocity is 20 meter per second. Strikes a target and comes to rest, which means in the end it is not moving, which means final velocity is 0 meter per second. After penetrating a distance of 10 centimeter. So distance traveled is 10 centimeter. I notice this is given in meter, this is given in centimeters. So let me just convert this. This will be equal to 0.1 meter. So let's see what I can do. What do I have to calculate? I have to calculate the retardation, which means I have to calculate acceleration. So A is equal to V minus U upon T. Well, final velocity given, initial velocity given, time not given. So this formula doesn't work. Let's look at S is equal to UT plus half AT square. S given, U given, T not given. So this formula also doesn't work, which means the formula which I'll have to use is V square is equal to U square plus 2AS. Let's try. What is the final velocity? 0. So 0 is equal to initial velocity is 20 into 20 because it's U square plus 2 multiplied by acceleration multiplied by distance, which is 0.1. So which is 0 is equal to 400 plus 0.2 A, which means 0.2 acceleration A is equal to negative 400. Therefore, A is equal to negative 400 upon 0.2, which is equal to 4000 upon 2, which is equal to negative 2000 meter per second square. Why is acceleration negative? Because the object is coming to a rest, which means it's not increasing speed, it is decreasing speed. This is a case of retardation. So let's read the question. Calculate the retardation. Since they've asked for the retardation, therefore I'll have to answer in retardation. Therefore retardation is equal to 2000 meter per second square. Thank you.